Right, hello lovely grade 11s. This is basically a revision video on trig measurement, specifically looking at the sine, the cosine and the area rule. These notes are available on the Google Classroom. Basically, what we are saying when we're doing trig measurement is we are saying you have 3 rules available if you are not working in a 90-degree triangle. By the by, in a 90-degree triangle, it's just easier to use ratio. So it's just easier to use the ratio where sine of an angle is opposite over hypotenuse, cos of an angle is adjacent over hypotenuse, and tan of an angle is equal to opposite over adjacent. However, that only applies in a 90-degree triangle, whereas these rules apply in all triangles. Technically speaking, these rules even apply in a 90-degree triangle. So you could use the sine rule, the cosine rule, and the area rule in a triangle that has a 90-degree angle instead of using the trig ratios. You are actually allowed to do that. Okay, let's look at the rules. The first rule, the sine rule, on your formula sheet looks like this. It says that the ratio between the sine of an angle over the side opposite to that angle, that's why it says sine of angle A over small a, which is the side opposite the angle, will be equal to the ratios of all those sine of angles over the opposite side. So that's why sine of angle A over side A will be equal to sine of angle B over side B will be equal to sine of angle C over side C. And you can write the reciprocals. So in other words, you can say the side A over the sine of angle A is equal to the side B over the sine of angle B is equal to the side C over the sine of angle C. Now, we never use all 3 of those ratios, we just use 2 at a time. So we might use those 2 to solve an equation. We might use those 2 to solve an equation. Okay, now when do we use the sine rule? The sine rule is specifically used when 2 sides and an excluded angle is given. Now, the word excluded angle just means that the 2 sides given do not contain the angle given inside the 2 sides. So an included angle would have been over here between the 6 and the 5, whereas excluded angles are outside those 2 given sides. So that's why 55 over there is in actual fact an excluded angle, and 8 over there is also an excluded angle. So the moment you have 2 sides and an angle, you can use the sine rule to get another angle, but specifically it has to be the angle opposite to one of the given sides. So that's why in this little example, if you're given the length of 5 and the length of 6, and you're given the magnitude or the size of angle of that angle, which is 55 degrees, you can then go and you can find the angle theta up there, because theta lies opposite the 6 meter. So that's why you can then go and say the sine of theta over 6, which is the side opposite to it, will be equal to the sine of 55 over 5. And you can then go and you can just simply say multiply 6 by this. So let me show you how this happened. So we can say it's the sine of 55 degrees over 5, and I multiply all of that by 6 over here. And then I end up with that 0,98298. And once I've got that, I can then just use the inverse sine to find the angle. So you go shift, inverse sine of that ratio, and that will give you the angle, which is 79,41 degrees if you round it off to 2 decimal places. Okay, so that's the first way to use the sine rule. The second way to use the sine rule is if 2 angles and an excluded side is given. So if you have 2 angles, then the side given must be excluded. It must not be included between the 2 angles. It must not lie between those 2 given angles. It must be outside, so excluded. Then you can also use the sine rule, and you can then use it to find the side opposite one of the 2 given angles. So that's why you can say x over the sine of 65 degrees is then equal to 8 over the sine of 52 degrees. And that's pretty easy. You can just multiply that by sine of 65 to get your answer. So those are the first 2 circumstances in which you can use your sine. But the sine rule also works if you have 2 angles and an included side. Now, technically speaking, the formula is not set up for 2 angles and an included side at all. But if I have 2 angles, I can use the sum of angles of a triangle to find the third angle, which means if I use angles of a triangle. So I've got those two angles, and I've got an included side, as you can see. Then I can get that angle by using the sum of angles of a triangle, and I can say that's equal to 63, I believe. Let's just double check. 180 minus 63 and 54 is equal to 63. So that angle is the same as this angle. But it's not to be, I didn't make that 63 because it's the same. I made it the same because it is sum of angles of a triangle. Okay. Then the moment I've got that angle, I can then actually go and ignore this one. And I'm back to two angles and an excluded side, which is exactly the same as the example that I did under 2. Okay. Then the ambiguous case. Now the ambiguous case, what that does, it means you have to solve two possible triangles. And the reason you have to solve two possible triangles is because the information given can result in one triangle that has an acute angle or a different triangle that could have an obtuse angle. So you have to be very careful with the ambiguous case. Please don't always do the ambiguous case. You will only ever do the ambiguous case, number one, if the correct information is given. And number two, if they give you a clue by saying, calculate the size of the angles. So instead of saying, calculate the size of one, they have to kind of lead you towards realizing there is more than one angle that you can calculate. So when do we use the ambiguous case? The ambiguous case is when you have two sides and an excluded angle. Two sides and an excluded angle, but the angle opposite the shortest side is given. So very, very important, the only angle that is given is not opposite the longer of the two sides. The only angle that is given is opposite the shorter of the two sides. So what I will have here is I'll have the following. I'll have two sides, 2,5 centimeters and 4 centimeters. And then the angle that's given is that 32 degrees. But that angle specifically lies opposite the 2.5 centimeter, which is shorter than the 4 centimeters. Which then means it could have looked like this. The 2.5 centimeters could have gone that direction, but it's also possible that the triangle could have looked like that. So that means you could have potentially had the green triangle, which satisfies all of the information given, or potentially you could have had this pink triangle, which also satisfies all of the information given. So that means there are two possible triangles that can be solved here. And that is why you need to solve for that angle as an acute angle, but you also need to solve for that angle as an obtuse angle. Simply because of the fact that over here, the sine of an angle is positive not only in the first quadrant, but also in the second quadrant. And that is why whatever reference angle you get, that 58, you have to go 180 minus 58 to get to that 122. So you have those two possible angles, which then means once you get those angles, you could also then have a different length of side here as opposed to the pink one over there. So just be careful, because if you do get those two different angles, you might be required to get the side over there. And if you're to get the side and that top angle, you then have to do it for both triangles. So that's an ambiguous case. Right, the next one, cosine rule. Now, in the cosine rule, pretty much, you are going to use two sides and an included angle. Right over there, two sides and an included angle. And pretty much what the cosine rule says is the cosine rule says that the side opposite the angle that was given, so c squared, if you want to use c, by the way. This one's set up for a squared. Let's go for a squared rather. So the side opposite the given angle, if they've given you a and they've given you those two sides b and c, then a squared is equal to b squared plus c squared minus 2bc cos of a. And you can do that with all the angles. If you go, for instance, and they give you angle c and those two sides that include angle c, then you're going to say the side opposite angle c, so c squared is a squared plus b squared minus 2ab cos of c. Or if they go and they give you that, they want the length of angle b, and they give you angle b, then you can say b squared is equal to a squared plus c squared minus 2ac cos of b. So specifically, this works when you have two sides and an included angle. So the two sides include the angle in between the two of them, and then you can use this cosine rule. just like in this example given. The cosine rule, however, can be set up for 3 sides. So if you have a triangle and you are given 3 sides, you can actually set it up, and this is something that is not on the formula sheet, but I did show you up here how to set it up. If you go and you say, for instance, 2bc cos A is then equal to b squared plus c squared minus a squared, then you can just divide both sides by 2bc to get this. So this one works if I have all 3 sides, but careful. If I want to get angle A, then the cos of angle A is equal to the 2 sides that include the angle. So that's b squared plus c squared minus the side opposite the angle squared divided by 2bc, which is again the 2 sides that include the angle. So just watch how you set this one up. So in this particular example, that's also in the notes, you'll see all 3 sides are given and they ask for this one. Okay, so the moment they ask for that theta, you have to realize the cos of theta is equal to, so look carefully, 3 squared plus 5 squared, because those are the 2 sides that include the angle. So it's 3 squared plus 5 squared minus 6 squared, because that is the side opposite the angle, over 2 times 3 times 5. That's going to be the cos of the angle. And you can then, once you've got that ratio here, you can use the inverse cos to get the angle. And there's no ambiguous case for the cosine rule. Okay. Then, the area rule. Okay. The area rule pretty much just says the area of any triangle ABC, will always be half side of the one side of the triangle times another side of the triangle times the sine, and careful of the included angle. Now be careful. I know we normally use 2 sides and an included angle with a cosine rule, but that's if we're trying to find the length of a side. So the cosine rule is used when you're trying to find the length of a side and you have 2 sides and an included angle. The area rule is used if you have 2 sides and an included angle, but you're trying to find the area. So please don't get the 2 confused. Okay. You can also go and you can say half b times c times the sine of a, or you could go half a times c times the sine of b. Okay. When do we use the area rule? Only when area is asked or when area is given. You never ever touch the area rule unless they talk about area, because that's the whole goal of the area rule. So if you don't want an area, you want an angle, or you want a side, you have to decide which of the 2, the sine rule or the cosine rule, you're going to use. And I want to remind you again, if you have 2 sides and an excluded angle, that's sine rule. If you have 2 angles and an excluded or an included side, that's also the sine rule. But if you have 2 sides and an included angle, that's the cosine rule. Or if you have 3 sides, that's also the cosine rule. And this is how you have to approach it. You have to know from the given information which rule to use. Thank you for listening.